viewers. By name's Luswata Simon Chiza. Welcome to Academic Lessons UG. This time round, I've come with probability scenario questions and responses. I've termed it episode 1 because many other episodes are still coming. This probability is suitable for all students in Senior 5 and Senior 6 offering mathematics. And those who have not yet subscribed, please do subscribe. You don't miss out other episodes that are to be uploaded soon. So let us venture into the first scenario and we see. So here we have a pair of fair dice. A pair of fair dice is rolled once. If the sum of the numbers that shows up is 7, you lose $11. And if the sum is 4 or 12, you win $13. How much should you lose or gain for any other sum in order for the game to be fair? Now here we have two dice. We know that a die is having numbers on top, is having 6 faces, 1 up to 6, and we have 2 of them. Let us first develop a sample space and see the sum 7 and the sum of 4 or 12. In this sum, we add the 2 faces of the die. For instance, if the first die is showing 1 and the second die is showing 1, it means that the sum is 2. Now, the first die is up here but horizontally, having the first face to the 6th face. Die 2 is vertical, having the first face to the 6th face. We are looking at sum. They are talking about sum 7, sum 4, or 12. So our concentration should be on the sum. Now, for example, if the first die shows 1 and the second die shows 1, if we add 1 and 1, we get 2. So this is our sample space we have. If the first die is showing 6 and the last die is showing 6, we add 6 plus 6, getting 12. It means our biggest sum in our sample should be 12 when both they have shown 6. So we are looking at 7. 7 is in blue. The first die can show 1 and the second die shows 6. The first die can show 2 and the second die shows 5 in a total to get 7. The first die can show 3 and the second die shows 4 in a total 7. Or the first die can show 4 and the second die is showing 3, the total 7. Or the first die can show 6 and the second one shows 6, the total is 7. So what is the probability of losing 11? The probability of losing $11 will be the probability of the sum being 7. So the probability of sum being 7, we count them. The 7s, 1, 2, 3, 4, 5, 6. So we have 6, 7 out of our sample space. 6 times 6, 36. So if you add up, you add sum all these figures in here, they'll give you a total of 36, which is reduced. If you reduce by 6, you have 1 over 6. It means the probability of losing 11 is 1 over 6, because if the probability of showing the sum 7 is 1 over 6, it indicates that the probability of losing 11 is also 1 over 6. Sum for all 12. These are the green numbers in the table. Wherever we have 4, all means plus. So we have 1, 2, 3, 4 out of the sample space, which is 36, which can be reduced to 1 out of 9, such that the probability of winning $11 is 1 out of 9. Remember, when the sum is 4, all 12, you win $13. So the probability of winning $13 is 1 out of 9. Probability of other sums. Because they're asking how much should you lose or gain for any other sums in order for the game to be fair. Now the probability of other sums, the total probability is 1. They have talked about the sum of 7, sum of 4 or 12. So if we get 1 minus these other sums we have, that is 1 over 9 plus 1 over 6. Then 1 minus this, we have 13 out of 18. Or if you don't want to do this, you count other sums we have not talked of. Those are black letters, black figures, black numbers in our sample space. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. No, they are 26. So 26 out of 36 reduced by 2, you have 13 out of 18. That is the probability of other sum. We want to get the money, the gain or lose for any other sums. We are letting it to be M. We can construct our table, and our X is the lose or gain. You can lose negative, you can lose 11, 13, you win 13, and M we don't know. Now, probability of losing 11 is 1 out of 6, losing 11. That is why we have attached a negative to 11, because we are losing it. Gaining is positive, gaining $13 is 1 out of 9, and we don't know M, what we gain or lose for other sums, but the probability of other sums is 13 out of 18. Now they are giving us a condition that in order for the game to be fair, since your expectation should be 0, because you put in $0 to go for the game. So what you put in is what you gain out. So for the game to be fair, so you expect 0 because you put in 0 when it was starting. So getting the expectation will multiply X times the probability. Summation of X times the probability. Multiply negative 11 times 1 out of 6 plus 13 times 1 out of 9 plus M times 13 out of 18. We equate it to 0 and we find M. You realize that our M is positive 7 out of 13. So it is a gain. So for any other sum, you gain 7 out of $13. That has been the first one. Let us venture into the next one. So we have number 2. In a programming course, the probability that a student uses an online tutorial to prepare for an exam is 0.4. If a student uses a tutorial, they have an 80% chance of passing the exam, scoring a pass or a distinction. If a student does not use a tutorial, they have 70% chance of failing the exam. What is the probability that a randomly selected student passes the exam? A student who passed the exam did not use a tutorial. Now, this number requires us to use Bayes theorem, because or if you don't use Bayes theorem, you can use a probability tree. So we can start by letting T student, let T be the students using tutorial, such that probability of using tutorial is 0.4. Then the probability of not using tutorial, T prime, is 0.6. That will be 1. The total probability minus 0.4, it is 0.6. PB, the probability of passing the exam. P prime, probability of failing the exam. Now, they are giving us a condition that if a student uses a tutorial, they have 80% chances of passing. When they give us 80%, they have given us probability. It means our probability, it is 80 out of 100. That is the probability of passing if a student uses a tutorial. Now, passing, given that used tutorial, is 0.8. Not passing and did not use a tutorial is 0.7. That is the assumption here. If a student does not use a tutorial, they have 70% chance of failing. So this is the condition. Not passing, given that use the tutorial. So we can draw our probability tree. Probability that is using a tutorial is 0.4. Then the probability that is passing when he has used the tutorial, this is the branch, is 0.8. Probability of not passing and use the tutorial, if probability of passing and use the tutorial is 0.8, then probability of not passing, P prime, when using a tutorial, this branch of a tutorial, we get 1 minus 0.8. 1 minus 0.8 gives us 0.2. This is the probability of using a tutorial. Now, probability of not using a tutorial, T prime, we found it as 0.6. The total probability here should be 1. So we get 1 minus 0.4, getting 0.6. Passing when he has used the tutorial is 0.3. And not passing when he has used the tutorial is 0.7. Now they want us to get the probability of passing. What is the probability that a student is randomly selected passes the exam? So there are two ways of passing. One can pass when you use the tutorial, and one can pass the exam when they did not use the tutorial. So we look at tutorial and passing, we multiply these two, and also not using a tutorial and passing, we multiply 0.6 and 0.2. So this is what we have: 0.4 times 0.8 plus 0.6 times 0.3. Then we have the total. There is a half. Probability of passing is a half. Then when we go to part B, a student who passed the exam did not use the tutorial. Now this is a conditional probability. This is the conditional probability we want. We want to find probability of not using a tutorial given that somebody passed. This is a given symbol which is expanded as this: probability of t complement intersection p divided by probability of p. Now probability of t complement intersection p, when we come to our probability tree, we look at this t complement times this p, that is the numerator term, 0.6 times 0.3 divided by probability of passing. Here the probability of passing, we have it in part A, which is 0.5. So our answer is 0.36. So we can see another number without taking much time. The probability, this is 3. The probability that a crime is committed in an area is 3 out of 10. And the probability that a wedding is held in this area is 3 out of 5. There is an 84% chance that in this area that either no crime is committed or wedding is held, or both happen. Determine the probability that a wedding is held and a crime is committed in the area. Part B, determine whether or not committing a crime in this area is affected by holding a wedding. Now this scenario, we can start by rating. Let's see be the event that a crime is committed, W be the event that a wedding is held, C prime be the event that no crime is committed. The probability that a crime is committed is 0.3 from the question. They gave us 3 out of 10, which is 0.3. The probability that we have a wedding is 3 out of 5, which is 0.6. Now, from probability that a crime is committed, we can find the probability of no crime, that is complement, C complement, which is 1 minus 0.3, which is 0.7. Then the other case, they gave us the probability that a crime is not committed or a wedding is held as 0.84. They are giving us percentage, 84%, that either no crime, that is C complement, or wedding is held, or both happening. Now that is the union. It is C complement union W, and it is expanded as this. We are looking at a wedding, a crime not committed, a wedding held, or both are happening. It is like we are looking at C complement intersection U, which is expanded as probability of C prime plus probability of W minus probability of both. So if we happen to substitute both the two, we can get the probability of C complement intersection wedding as 0.46. Remember, this is not what they want, but we can first determine it. What we want is the probability that a wedding is held and a crime is committed. A wedding is held, and a crime is committed. A wedding is wanted and a crime is committed. Now, for this particular case, after getting a crime committed and a wedding is held as 0.46. When you look at this complement, means not committing a crime. So it means they were finding the probability of W. This expression can be found there, or one can use a contingency table, that the probability of a wedding is the probability of the intersection plus probability of wedding only. Remember, we have this. What do we want? We want this probability of a wedding held and a crime is committed. So we substitute a wedding, we substitute this which we have found earlier, such that our probability of both wedding and a crime is 0.14. Part B, whether or not committing a crime in this area affected by holding a wedding. So they are looking at independent events, and the condition for independency is that the intersection is a product of individual probabilities. So they want us to prove that the intersection is this or not. Now if we multiply the individual probabilities, probability of a crime and a wedding, we get 0.18. So the conclusion is, since 0.18 does not equal 0.1, since 0.14 does not equal to 0.18, the condition this is false. The answer is the event are not independent. Therefore, committing a crime in the area is not affected by holding a wedding. We have another one. This case here is a text from read a copt. This is what we have. Joel enjoys challenging games, challenging his friends in different games at school. Always Joel plays one opponent and takes on the first turn. We are saying each game is limited to at most 5 turns. So mark this word, 5 turns of Joel. Game R, Joel and his friend roll a fair dice in turn. Turns, the first person to roll a 3 wins. Game S, Joel and Ali takes turns shooting at a target. The probability of hitting at a bullseye are 1/3 and 1/4 respectively. The first person to hit at the bullseye wins. Then game T, Joel and his opponent roll a fair 4-sided dice in turns. The first to roll a 4 wins. Thus, determine the probability that Joel wins. Part A, each of the 3 games R, S, and T. Part B, all the 3 games. Part C, none of the 3 games. So we can start by let PR, PS, PT be the probability that Joel wins game R, game S, and game T respectively. Game R, Joel wins on the first, second, third, fourth, or fifth turn. We are looking at 5 turns of Joel. Since we are looking at 5 turns of Joel, and Joel comes first, so can win the first, or on the second, or on the third, or on the fourth, or on the fifth turn. Joel wins by rolling a 3. So the probability of rolling a 3 showing on top for a die is 1/6, and the probability of not showing is 5/6. So let us see the probability of Joel winning. Now, Joel takes on the first turn. this 1/6 Joel can win on the first trial, and then the game ends. Or Joel can first lose by showing other figure not 3. A friend should also lose, Joel to come back for the second time and wins. So this second term Joel can win is the term that shows that Joel is winning on the second turn, on his second turn. First turn, a friend loses, Joel again wins. Then Joel can win on the third turn. Joel lose, a friend lose, Joel lose, a friend lose, and Joel wins on the third turn. Plus up to the 5th term. Now we can rewrite this. 5 times 5 is 25. 6 times 6 is 36. And this term will be 25 out of 36 squared. Now this one is forming a GP with the first term 1/6 and common ratio 25/36. We can get it from the formula of a sum of a GP, which is a into bracket 1 minus r power n, 1 minus r down power n, the number of terms. We want to add them up to the 5th term. That's why there is a 5. So the probability of Joel winning game R is 0.45736. Then the probability of winning game S, we have the probabilities of hitting the target, the bullseye. The probability of Joel hitting the bullseye is 1/3, and the friend is 1/4. So if we have their probabilities, we can get the probability of not hitting the bullseye. So the probability of not hitting the bullseye for the case of Joel, it is 1 minus a third, which is 2 out of 3. And for a friend is 1 minus 1/4, which is 3 out of 4. So the probability of Joel winning, Joel can win. Remember, he takes on the first turn. He can win on the first trial, 1 out of 3. Or he can win on the second trial, that Joel is failing. This probability of Joel failing, 2 out of 3. And the friend is also failing. Then Joel comes again for the second turn and he wins. Plus, Joel can win on the third turn. He fails first, friend fail. He fails the second time, a friend fail, and he wins. These, we multiply them because they are two independent events. The probability of Joel losing for the first time does not tell us how a friend will perform. So they are independent events, we multiply them. So they are making a GP3 with the first term 1 out of 3 and the common ratio 6 out of 12, such that we get their sum, the sum of the first 5 terms as 0.6458. Then a 4-sided dice, 4 sides, it is having 1, 2, 3 up to 4. The probability of losing is 1/4. And the condition was showing a 4. If we remember very well, Joel and his opponent roll a fair 4-sided die in turns. The first one to roll a 4 wins. That is why we are saying the probability of getting a 4 is 1 out of 4, as the probability of winning, and losing is 3 out of 4. So Joel can toss the first time and wins, or can fail, a friend fail, also wins at the second tossing. This forms a GP with the first term a quarter and common ratio 9 out of 16, which we can substitute in the formula. which is A into bracket 1 minus R squared divided by 1 minus R. We have it as 0.5392. Those are the probabilities of winning the game R. Now the probability that Joel wins all the 3 games, can win game R, game S, game T. We get the intersections. So we multiply the individual probabilities, starting with game R. Then there is game S. This was S, not R, game S. And the probability of game T, this was T. So we add the probabilities and we have something of that kind, 0.15926. Then the probability that Joel wins none of the games, we have the complement of them. We complement this because he's winning none. To get the complement of R is 1 minus its probability. To get the complement of S is 1 minus 0.4573. Get the complement of T is 1 minus 0.6458. And then we have our probability as 0.088567. Then another one, we have a food critic is judging a cooking competition and rates dishes on 3 criteria: taste, presentation, creativity. The criteria are weights. Taste has a weight of 6. Presentation has a weight of 8. And creativity weight 11. One chief judge receives scores of 65% for taste, 85% for presentation, 70% for creativity. Creativity, then they want us to calculate the chief's final overall score. If they are giving us the weights of presentation, of creativity and taste, and we have their respective scores. So here we can develop a table. These weights can act as frequencies. We have criteria, scores, test 60, weight 6. Then the total scores, weighted scores. It is like getting fx if this is x, and frequency is like getting you are given f and you are given frequency. This way it can act as frequency, and we want to get the mean, so we multiply scores and weights and we have a total. This is our total, so our final score is total weighted score. This acts as a summation fx out of summation f. Weight can act as frequency. This can act as summation f and x. So the final score is 73.6%. So thank you for watching. We meet in the next episode 2. Goodbye.